Welcome back. Not many people are in an IDF keynote back-to-back years, so you're very special.
Yes, I'm very glad.
All right, you got a server array sitting here. Why don't you tell us what you've done?
Yeah, so as you mentioned, Justin, so last year we demoed a single IoT base station running on servers. So we made a lot of progress since then. So today I can show you multiple base stations running on servers, and the load can be shared among different servers, as in C-RAN base station 2.
So we have a little Cloud RAN running right here?
Yes, you are right. So here you can see we have two Intel Core i7 servers, and they are running base station workload, and we also have emulated mobile devices connected to the base station and playing streaming video. So
okay. So can you make it go?
Yeah, here, so I start with the configuration, and we have only one server is running and processing two base station workload. Each base station has fewer mobile devices. So as I add more mobile devices into this network, so you will see the load of this server start to increase, and this is the type of scenario we see every morning, such as more and more users come online in office area.
Right.
And then, one of the base station can be offloaded to another server. So in order to do load balancing and also to support more users and the throughput.
I mean, these days, right, the base stations are typically over provision. Right. They're designed for the expected peak load, right? And so you wind up with a lot of hardware in the field that you can't really bring into play when hotspots develop in the network. You can continually balance the load.
Yes.
That's fantastic.
This is wonderful, but Sunny, I have a question, because actually there's another challenging situation we would like to deal with, which is when like at midnight or off-peak hours, when the traffic load actually is not that high. Can you somehow help us to conserve the energy in the system when we don't really need that many processors going on?
Oh yeah. So in addition to the load sharing, when the traffic load is high, and our C-RAN prototype can also consolidate multiple base station workload into a smaller number of servers.
There you go.
Such as one turn off to mobile devices, and then you can see one of the base station can be moved from this server to another server, and then so we can turn off this server in order to save energy.
Right, and I imagine, as you say, in lightly loaded situations, that could save a tremendous amount of power. Because in the current model, those guys are up just all the time waiting for traffic.
Yeah,
exactly.
All right. Well, that's really great. So if you're going to come back for a third year, you got to do something.
I hope so.
You got to do something really cool. No guarantees. I'm not making any promises. We'll delete this part of the video.
No. Wait. Let's try to make a promise. I think the next we really have a few more, even higher challenges to deal with. Can we put it out here?
All right. Let's put it out here.
Okay.
So what's next?
Yeah. So
the next virtualization, maybe.
Yeah. So right now, so we are continuing working on the C-RAN architecture optimization. So we want to support a different loading level for different scenarios. So our research target is to support up to 100 base stations in just one server when the load is light.
100 base stations on one server. Wow.
So that's our research goal. So.
Okay, you do 100 base stations, I'll bring you back next year.
Okay, that's a problem.
All right.
Yeah.
That's a problem.
Okay.